Good morning, good day from the Radiant Professionals Alliance. I'd like to welcome you to the February 21st presentation of HydroniX Talk, which is a presentation of the Radiant Professionals Alliance. I am your host, Mark Etherton. Here's some information on me. I am the current Executive Director of the RPA. I've been a member for the last 20 years. I'm a contributing editor to Contractor Magazine. I've been an educator for about 39 years. I'm a former expert witness and am still a current licensed master plumber here in the state of Colorado. Quickly go over some rules of the road. If you would please use headphones with a boom mic if possible. That will avoid feedback occurring whenever we decide to enable your mic if you have a question to ask of me. If you have a question that you would like to ask, you can enter it into the Q&A type box. And we'll bring it to my attention, and then I will let our guests know that they have a question, and if need be, enable your mic so that you can ask them physically yourself. Questions regarding the presentation may be responded to after the presentation, unless you deem it very important, in which case let me know, and I will break in and interrupt our speaker and have him address your questions specifically. Trade section will follow the presentation. I'd like to thank everyone for attending. Here's some of the alternative radiant panels that I'm a big fan of. I've got radiant floors, radiant walls, radiant ceilings, and even some radiant windows in some of the houses that I own and operate. And I think radiant floors are great, but if we as an industry are to sell more of these to the Joe and Jane six-packs of the world, we're going to have to look to an alternative surface. And as houses get even more efficient, then panels like this become even better in their application. This is a project that we did for the National Renewables Energies Laboratory in conjunction with the Habitat for Humanity project, and that works fantastic. The house has got radiant walls throughout, and it's also tied to solar, and at the time that it was installed, it was one of the most efficient homes in the world, according to the people that performed the audit on it. Here's a radiant ceiling system that I installed on my own house up in the mountains. This is part of actually getting the tubing installed, and as you can see, it's in a state of disarray, which is typical for a construction site. Here's the only advertisement that you'll see during this show. If you would please, we would love for you to join the Radiant Professionals Alliance. These shows, as they are produced live, are available to anybody that has the inclination and time to come listen, and they are archived after the fact for our members only. So if you missed a section and you want to go back and see it, you'll have to become a member of the RPA in order to be able to gain access to it. This talk show occurs every other week. This is the 10th show that we put together. And we have open Q&A sessions following the interview. So if you've got a problem, a nagging problem that you don't seem to be able to find any resolution for, by all means, bring it to the forefront, ask the questions. All participants are allowed to chime in and have input into it, as well as our guest speakers if it's an area of expertise that they can answer. The shows, as mentioned previously, are archived for members only to be reviewed at a later date. These shows are meant to be fun, educational, entertaining, and fun. And if you have a guest interviewee that you would like for me to take into consideration for this show, by all means, forward his name to me, and we'll be glad to take it into consideration. Some hydronics news that you can use. We have these courses that are currently being offered through HeatSpring. We have the fundamentals of radiant design. We've also got a class on 4 different storage strategies for integrating solar and hydronic heating. And then we also have numerous other courses that will be coming to the forefront in the very near future, which are currently undergoing some marketing research to make sure that it's worthwhile for the instructors to bring them online. But they will be courses, as an example, on blueprint reading, which a lot of people don't think they need, especially tradesmen, because they've been reading floor plans for their whole life. But this course goes much deeper than that and shows you what all of those other little dashed and dotted lines that are on those drawings mean. And once you understand what those lines mean, you'll find that your job becomes much more easier as an estimator, because you realize that you really can't rise vertically there because there's a major I-beam there, or that you can't run your pipes horizontally there because you've got a major structural consideration. So we're trying to make some courses for our contractor membership base They can take these classes at their convenience. They don't have to be at a certain place at a certain time, and unless they have questions for the instructor, in which case there's a meet the instructor session that happens once a week during the course event, and you can ask them any questions in regards to the course material. As far as conventions are concerned, the MCAA annual meeting is going to be March 8th to the 12th, and the information to be received there is shown on the screen at mcaa.org/MCAA 2014. Not really sure why they have the wrong date on there, but the ACCA show is going to be down in Texas this year, and that's March 16th to the 19th. Additional information can be gotten at acta.org. And then, of course, there's the ISH conference in Frankfurt, Germany, which is March 10th to the 14th. And I know my friend Dan Holohan and numerous other people that I'm very familiar with will be going over there. Personally, I think this show is misspelled. I think they forgot to put the W on the front of it because a lot of the stuff that you see over there, although it's neat and interesting, will probably never make it over to the side of the pond. And then the Indoor Air Quality Association has a meeting on March 16th through the 18th, and their website is www.iaqa.org. I wanted to talk a little bit briefly about the AHR 2015, which we just ended up completing. It was a smashing success. We had 6 classes that the RPA presented, and had over 180 attendees that were registered. And I know that there were a number of people that came in after that list had passed through, so I'm guessing we probably were somewhere around 200 people total. We had roughly 40 attendees attend the RPA annual meeting and elected our officers. All of our top officers have been reelected, so we're good to go for another 2 years. And then we also had a social soiree, and at the social event we had over 50 people in attendance there, and it was great to see a lot of people that were showing up at that social event. Quite honestly, I wasn't expecting a whole lot of turnout, but it worked out quite well. Next year's show is going to be in Orlando, Florida. Here's some pictures from the social event. You can see that we have Bob Rohr and Dan Holohan, and there is Ellen Rohr, and also Jackie Schrock, who is our recording secretary-treasurer. And then there's Dave Yates and Dan Holohan. Both Dave and I actually started writing for Dan a long time ago, about 19 years ago. He's the one who got both of us into business. And then on that lower right-hand corner is a picture of one of our presenters, which was Colin Wonder. And it was good to see him, and I believe if you look real close, no, she's just outside of the picture. Actually, Claudia was in there. Here's our required image disclaimer from our lawyers. The graphics and illustration used in this webinar are presented for educational purposes only. RPI-APO does not endorse or recommend the vendor or product depicted, nor any vendor or product. RPI-APO makes no representations, warranties, or guarantees as to and assumes no responsibility for the product depicted. RPI-APO expressly disclaims all liability for damages of any kind arising out of the use of or performance of the vendor's products or services depicted. Out of wind. So today's topic. Today's guest speakers will be Bristol Stickney and Claudia Pavel with Solar Logic. Good morning.
Good morning.
Morning, Mark.
Morning. How are you?
Pretty good.
Good. Wanted to thank you both again for having you show up at our show for the 2 presentations that you provided us with. I think it was very well received. I know that there were a lot of good questions that were asked afterwards, and I just wanted to make sure that you understood that we very much appreciate the efforts that you put forth. And at this point, I'm going to go ahead and turn it over to you two and let you two take the show from here.
Okay, have you given me the control over the slideshow?
That would probably help, wouldn't it?
Okay.
And transferring the ball of power to you.
Okay.
It's all yours.
All righty. I'm going to try to get to my first slide here. All right. Well, the subject of our talk is what we call new standard solar hydronic combi systems. And just to give you a little background, Claudia is the Director of Sales and Marketing here at Solar Logic in Santa Fe, New Mexico. And my name is Bristol Stickney, and I'm the Chief Technical Officer here at Solar Logic in Santa Fe, New Mexico. And the Solar Logic part of our business provides design assistance for solar hydronic combi systems, and we also manufacture a patented control system that plugs into solar hydronic combi systems and makes the installation of the system and the startup incredibly simple, since there's no programming in our controller, and it's designed along with the plumbing to just plug in and work. So that's what we do at Solar Logic, and as you can see from this slide, we focus on modular design, so doing plumbing systems over and over again in essentially the same way as much as we can. We'll get a sort of a modular design that we know how it works, and then we'll just use it over and over again. We use integrated controls. That is, whenever we design plumbing systems with hydronic pumps and zone valves and sensors and so forth, whenever we design the plumbing and the components, we simultaneously design the control package to go with it at the same time, so that they're designed to go together. And then all of our control systems are internet enabled. That is, you can watch them over the internet, and you can they data log, they record everything they're doing, and you can watch that over the internet. And then they give you energy measurements, and they allow you to do remote control. You can actually control the system and adjust the system completely over the internet. So that's what we're about at Solar Logic. Our focus is on solar hydronics and combi systems. So that goes right along with the Radiant Professionals group. We're all about hydronics. The stuff we're going to be talking about today in this presentation is both for existing building and conventional buildings, and it's for new and retrofit solar heating systems that involve hot water boilers and hydronics. We're going to focus only on proven concepts that are things that work. And by things that work, I'm talking about things that we put in the field over and over again so many times that there's no question that this approach works. And then I'm also going to be mentioning some advances and innovations in solar heating that go along with what we do. These are things that work that are kind of new, but we use them because they work. And keep in mind that everything that we do at Solar Logic in terms of designing hydronic systems and controlling them is all done to a standard way of doing things. It's scalable, so you can make the standard way bigger or smaller and it still works. And it's repeatable, so you can repeat the same thing that works and make it bigger or smaller over and over again in different construction projects. So let me show you 3 examples of what I'm talking about. As I said, I'm talking about existing buildings that have been installed and work out in the field. And if I might get Claudia to talk about this building, if you can unmute yourself.
Sure.
Hey, just give us a description of what we're looking at here.
Well, this is the Los Alamos Echo Station, and it received actually a couple of awards, first place awards from RPA. You can see it. It's on the cover of the Radiant Living magazine that they put out. It's also a LEED silver building, and it was done probably 6 or 7 years ago. They installed 2 types of solar panels. What you see on the vertical panels, those are solar thermal for heat and hot water. You can also do cooling with flat plate collectors like that, but they wanted additional cooling. So on the bottom left, that picture you see there is a collector system that is they're unglazed collectors, and so they're specifically for the night sky radiant cooling feature. So what happened with this particular system is Bristol designed it originally, and then several years later, a heavy hailstorm took out the plastic collectors that were originally used, and so at that time they decided to not only replace the collectors but also to update their control system. The design of the system is exactly along the standards that Bristol's going to go through, and it was easy to upgrade their system as far as controls went. And again, Bristol will talk more in details about what that system is. But in any case, we did get some awards for it. They were certainly pressed for it, and more importantly, the client is incredibly happy with the results of their system.
All right, thank you. The client is the County of Los Alamos in Los Alamos, New Mexico, and it's actually the recycling center in the city of Los Alamos. So it's a good example of a public building that's small commercial that uses hydronic heated floors and solar heat to heat the floors and the water heater in the building, and also radiant night sky cooling panels that are activated in summertime to pre-chill the concrete floor every night, so to avoid operating the air conditioner during the day on the following day. That's a feature. That night sky radiant cooling feature is something that we put automatically into every control system we build, and you can either use it or not, but it's there in every control system. Now I'm going to show you two more examples of real installations of new standard solar hydronic heating and cooling systems. The next example is a residential house that's you can see when I took the picture it was a construction site, but the owners have been living in there for almost 2 years now, and you can see that it's just a standard Santa Fe style residential building. Again, it has slab-on grade, well-insulated, radiant-heated floors that are, concrete and brick-on-sand and, masonry materials. And so we designed this building around the new standard solar hydronic principles to include solar heat collectors on the roof. And you can see that they're mounted the low way, the low profile way, so that they don't really stand out very much. And in fact, to see all the collectors, you actually have to climb on the roof because you can't see them all from the ground. And that's what the picture on the left is. The picture on the right shows you the boiler room with one of our solar logic controls hanging on the wall, controlling all of the heat and cooling in the building. And of course, this building is heated by the solar collectors in winter, and then when the controller switches over to cooling mode, you can pump fluid out of the floors and up to the collectors at night to chill the floors. And so they do that. The next building that I'm going to show you, the third building that's an example of the kind of thing we do, is a retrofit we did in Virginia, in a town that's about a 2-hour drive from Washington, D.C. There was already a slab-on-grade hydronic heated floor on the first floor of this building, and then the second floor had hot water radiators. So we used the standard plumbing design that we always use to connect solar collectors to reduce the use of his hot water boiler. His hot water boiler was burning fuel oil, and we put in enough collectors to reduce his fuel oil consumption by 50 or 60%. And so we use the solar heat capacity of the floors, the thermal capacity of the concrete floors that are well insulated, are capable of storing quite a bit of solar heat. And so our controller always takes advantage of that. And whenever it can charge up the floor up to a comfort temperature with free heat, it always does that. And when you use the concrete floor on a relatively reasonably sized bank of collectors like this, you can usually control the heat so that most of the heat is stored in the floor and very little extra heat storage in water tanks is required. And in this building, to heat the upstairs where there was no concrete available to store heat upstairs, we did put in 120-gallon water tank heat storage so that the upstairs could be heated at night by the stored solar heat. So that's the kind of thing we do. We're focusing on smaller buildings because big buildings have energy management systems that have been available to them, for decades. But small buildings have not. Small buildings have sort of missed the energy management revolution. And so we started at Solar Logic with the idea that any house, any hydronically heated house could have solar and could have energy management system added to it that was intelligent. So let's begin by describing what is the new standard integrated approach for hydronic solar heating, and I'd like Claudia to pitch in on and explain this diagram. What do we mean by the new standard? What's involved here?
All right, so this is a model that we use all the time. This is the only way we do things, which is that we've landed on a standardized plumbing design that is remarkably flexible and can accommodate for multiple renewable energy sources. And when you have a standard plumbing system, what you find is that you have the ability to control it in a standard way. And so again, with what we provide as far as the technology, the SLIC controller in particular, we don't customize that piece of equipment for your job. We don't do any original programming for every system that we send out. It arrives ready to plug and play, and that's because we do things the same way. If you have a wood boiler in your system, you can use our SLIC controller. If you don't have a wood boiler, that feature is just not enabled. So, and then the final part is important to the customer especially. They may or may not be interested in accessing their heating system, their entire heating system on the computer, but they obviously are interested in their own comfort, and so we make it easy for them. That fingertip comfort control is essentially a thermostat, so they can dial in the comfort they want. They could also switch off to something that's more that saves more energy in a particular room if they want to, but the point is it's easy for them. They don't have to use a computer.
Okay, thank you. So the idea is all the piping is done in a standardized way that's repeatable, that's similar from job to job, and because of that, a single kind of control system can always be used, and the parts that you need are enabled and the parts that you don't need are not enabled, so there is no custom software programming. And for everyone in the house, they can just turn up or down the thermostat the way they always do without knowing that a super intelligent control system is reading their thermostat settings and deciding for them to use either free solar heat or more expensive backup heat or transferring heat from a storage tank to somewhere else. All of that is invisible to the user in the house. The user just needs to turn up or down the thermostat. So let me go on and explain in more detail each of these three items here. First of all, the standard plumbing that we have landed upon after, I've been doing standard plumbing like this. I standardized it for myself and my own work over 15 years ago, I guess. I standardized on always using a primary loop or some kind of hydraulic flow separator. And I've tried both. I've tried primary loops and flow separators, and I've decided that for better control and better monitoring, the primary loop actually works better. So almost always we use a primary loop instead of a flow separator, The primary loop provides the flow separation, but it also provides temperature staging where you can put different temperatures in order along the flow path of the primary loop. So for instance, the solar collectors can, through this heat exchanger, feed a storage tank, which can feed a boiler, and so the temperature goes up and up as you go down the flow path of the primary loop. So you have this rising temperature order for the heat sources, and then you have diminishing temperature order for the heat loads. So the first heat load we almost always have right next to the boiler on the primary loop where the boiler fluid is the hottest is the domestic hot water tank, so that you can have fast recovery for showers to prevent the occupants from complaining. You always want to do fast recovery for showers at the hottest temperature. But then as you've delivered your heat to the water heater, you have some leftover heat that goes down the primary loop, and it still might be hot enough to heat non-mass floors like low temperature radiators, or mass floors like standard concrete radiant heated floors don't require super hot temperatures. So you might take the remaining temperature from these higher temperature jobs and heat the floor with it without really running the boiler anymore. And so we use the primary loop for temperature stratification, for separating out a hot end and a cold end, and putting our high temperature devices first and our lower temperature devices second. The other innovation that we've got here is that we can extend the primary loop that's in the boiler room to the outdoors by putting a heat exchanger on the primary loop and filling the outdoor plumbing with antifreeze. And of course, we use boiler and solar compatible propylene glycol antifreeze, a water to antifreeze mixture, typically 50-50 or 60-40 water to glycol, that sort of thing. So we have two, in many cases, we have two primary loops, but they actually act like they're one because there's just a heat exchanger between the glycol and the water, and we're extending the primary loop function to the outdoors to collect heat that's outdoors. If you have solar collectors, you collect heat using the glycol, or out here you can plug in a wood-fired boiler and heat water with wood and collect that heat through the glycol, and then put it through the heat exchanger and get that heat indoors around the loop where your intelligent control system puts it where it's needed most. So using this configuration, we have quite often one loop indoors with boiler fluid and one loop outdoors with glycol, and you can connect every heat source and every heat load with two pipes to either part of this primary loop. So you see the typical closely spaced T's plugging in your heat storage system or your boiler or your indirect water heater, heat exchanger. Everything is plugged in with closely spaced T's around a primary loop in a particular temperature order. And that's what we mean when we say new standard plumbing configuration. This is the plumbing configuration we always use. We always use the temperature order in this order around the loop, and we can plug in any heat source that you want, whether it's a heat pump pumping heat into a storage tank, or a wood boiler outdoors, or a wood-heated coil in a fireplace indoors, or an engine generator with waste heat being generated outdoors. No matter what kind of heat you have, you can plug it in with two closely spaced T's in the right order somewhere on this loop, and our control system will control it because our control system expects it to be like this. And then also you can see that we often put in swimming pools and hot tubs connected with two closely spaced T's somewhere in the loop, either the outdoor loop and heat it with glycol, or the indoor loop and heating it with boiler fluid. If you have swimming pools and hot tubs, it quite often makes alternative energy more economical because of the load of a swimming pool can be quite high, and if you throw some alternative energy at it, you can save a lot of money, a lot more money than just an ordinary home heating system. Also, you can see we often do ice melt or what you call snow melt zones, and we just take the same glycol that runs through the solar collectors around this loop and melt ice with it under intelligent control using the solar first and the alternative energy first and the boiler last. And keep in mind that the kind of heat exchanger we use here between the water indoors and the glycol outdoors is typically a reversible heat exchanger. You can make the heat come from the solar, come into the building, or you can make the heat from the boiler, go around through the heat exchanger and go outdoors. So no matter where the heat source is, you can make the heat go from anywhere to anywhere, into the building or out of the building, and to any heat load in the right temperature order. So this is the new standard plumbing configuration. And let me just show you another version of it. Here's a lot more detail. The first drawing I just showed you was just a block diagram showing you how closely spaced tees in a primary loop work. This is an actual, you could actually use this as an installation diagram if you're an experienced installer. And this plumbing detail actually comes out of a free software program that we have on the internet. You can go to the web page for what we call the /D Design Assistance Software and use it for free. And this is how we design our systems, and you can just design systems like this for free, just like we do, using the /D software for free on the web page. You can go to our web page at solarlogicllc.com and follow the links to the /D. /D stands for Solar Logic Assisted Solar Heating Design Software. So it's plumbing design software that kind of helps you describe what your job is like, and then it draws a plumbing diagram for you, and this is the kind of plumbing diagram it draws. It shows you where to put the closely spaced tees around the indoor loop with water, boiler fluid water in it, and then it shows you where to put the heat exchanger, and it shows you how to configure the outdoor primary loop with glycol in it. It shows you where to put the pumps, and then the relative location of all the other parts, that the boiler comes first around the loop, the water heater next, the space heating next, and so forth. So we've turned our standard hydronic design that we use all the time into a computer program so that anybody can do the same thing we do, and they can do it free using our software. And it's really helpful because you can design an entire solar Combisystem hydronic heating and cooling system for a project of the size that we typically do, which is small buildings less than 10,000 square feet typically is what we're working with. And you can do the entire design just talking to the owner or designer of the building and entering information about the building as the owner tells you what it is. And in about half an hour, you've got one of these plumbing diagrams, and then you can tune it up, tweak it, add more solar collectors, and the program tells you what your savings is, and so you can tune it up to meet the expectations of the owner, and then you can actually print out the plumbing diagram, and you can also print out the parts list with the prices in about an hour. So what we're doing here is we're creating a really easy way to solar heat hot water boiler systems in any of your smaller buildings, and it's so easy and so reliable that it's kind of ridiculous if you don't do it. And so we do it on all of our projects, and we've done somewhere between 100 and 150 projects in the last 10 years, and they're all like this. They're all primary loop systems with heat exchangers and solar collectors and intelligent control. So that's how you do the plumbing. That's what we call standardized plumbing, and we make it really easy by giving you free software to help you do it. I'm going to try to advance to the next slide here. And this is what we're trying to avoid. We're trying to avoid the way it used to be done in the 1980s, and where A plumbing installer would go to a plumbing warehouse and load up their truck with parts, and the guy at the warehouse might sketch out a pencil diagram of how they think a solar heating system should be put together, and then away they go with the parts and they try to kind of invent it as they install it. Here on the left is an actual solar heating system in Santa Fe that was invented by 3 different plumbers, one after the other, as each one tried and gave up, and the next one tried and gave up, trying to figure out how to put together what I call Combi 101. The Combisystem 101 is the solar heating system that pretty much everybody wants on their residential house. It's got a boiler, it's got solar collectors, it's got a domestic water heater tank, and it has space heating. So there's Combi 101 has 4 things: a boiler, solar, water heater, and space heating. And so you see in this diagram there's 4 pumps, one for each of those 4 things. But then if you follow our way of doing new standard hydronic design, you turn this kind of messy plumbing, kind of random piping configuration and turn it into a nice neat loop, and you connect your 4 things to the loop with 2 pipes, and you can see there's 4 pumps here, 1, 2, 3, and 4. The 4th one is the solar pump that's in the solar module. And you can see the heat exchanger hanging there on the primary loop. It's a flat plate heat exchanger that actually becomes part of the primary loop. The water side of this heat exchanger is in the primary loop indoors. And in this variation, you can see that there's swing check valves in between the closely spaced T's. And that's an innovation that we've invented here and been using for about 10 years. We call it the primary check loop, where if you put check valves between the closely spaced T's, then you do not need a primary pump. The check valves force the flow around the primary loop in the right direction whenever a secondary pump turns on. So for small systems, you can actually eliminate one pump, the primary pump, if you do these swing check valves the right way. And our /D design program will actually do that for you. It'll show you where to put the check valves if that's what you want. It'll also show you where to put the primary pump if that's what you want. So we're trying to avoid the messy old school way of doing plumbing, sort of shooting from the hip with a pile of parts, by having a very neat standard way of doing it and connecting all the components in the right temperature order in a very neat way. And if you do that, then you can control it in a very neat way, and you can guarantee the control is going to work right. So here's the control part of it. Our controller is, we call it the SLIC. It's the Solar Logic Integrated Controller. And we invented it from the ground up starting about 6 years ago. And what we did is we took every control item that's usually in a hydronic boiler room and we put it into one box and put all that stuff under computer control in the one box. So all the wires from the heating system come in through the bottom and connect to screw terminals on the bottom of this box, including the circulator pumps, the motorized zone valves, the end switches, the temperature sensors, which are typically 10K thermistors. All the room thermostats connect to this box. And because everything in the heating system, all the sensors and all the pumps and all the zone valves and all the switches are connected to the box, that means that the computer can see their state. The computer can see, is the pump on or off? Is what temperature is the sensor telling me? What is the room thermostat calling for or not calling for? Everything about the heating system is processed by the computer, and then the computer has this intelligent software that decides what to do. If there's free heat, we'll find something that needs free heat and send it there. And if there's auxiliary heat, we'll wait a little bit until the temperature drops a little, and then, okay, we'll fire the auxiliary heat as a last resort. And that's all of those functions, those intelligent functions, are built into the control system. And there's more functions than you can even imagine built into that software. And I'll get into that a little bit later on a later slide. And our philosophy is that good hydronic plumbing is useless without good controls, and that photo of old school proves the point. You can put, even if you're a good plumber, you can put together plumbing, but if you don't have a control strategy that goes with it, then the plumbing's out of control and it's useless. So we always design the plumbing and the control together, side by side. And our second control philosophy is that the plumbing and controls must be thought of as two parts of the same coin, or two sides of the same coin, if you will. And number 3, controls are not an afterthought. Even if you're a good plumber, it's a bad idea to create a complex alternative energy control, plumbing system, thinking that you'll figure out the controls later as an afterthought. That never works very well. So if you do standardized plumbing, you can do standardized control. And we have standardized our plumbing and made it simpler by using a primary loop, and we've standardized our control and made it simpler by using a computer and circuit boards rather than the hand wiring that we used to do. This is one of my really old solar heating controls that I put in a famous movie star's house here in Santa Fe about 10 years ago or 12 years ago. And you can see that there's hundreds and hundreds of hand wiring that is done. Wiring relays together, wiring solar controls and set point controls, and other things, time delays and what have you. In order to get all those intelligent functions, we used to do it manually with wiring and individual controls. And now we built all that intelligence into the computer software. So now it's all done with software. And there's essentially no hand wiring of the internal controls in the box. The only hand wiring is connecting each device to the controller one by one. Each pump gets controlled, gets wired to the control box, each zone valve and each end switch and so forth. So all the wiring is home run to the box. Every device has a place to go, and you put it there in the box. So here's a list of, this is a kind of an overall list. If you listed all the functions that are built into the SLIC controller in its software, it would be many hundreds of functions. But this is the big picture. We do two-stage controlling of almost every temperature in the system. And what that means is that every temperature that needs to get, every heating load that needs to be heated can have two set points, a little higher when the heat is free and a little lower when the heat's not free. And that's called two-stage thermostat control. And every device in the standard heating system that we do has at least two stages, so that we can, bump it up and store heat by raising the temperature when the heat is free, and reducing the conventional fuel when the heat's not free. Solar and backup for domestic hot water, that's the kind of function that you get from a typical differential thermostat. We have the equivalent of many differential thermostats built into our software. Solar heat storage in water tanks or in mass floors. Well, most old school solar heating systems had water tanks, but almost no old school solar heating systems even considered the mass of the concrete floors as a storage medium. And we've discovered that mass floors, radiant heated concrete floors, have so much thermal storage mass in them that sometimes we can just use that mass under intelligent control, keeping the concrete at a comfort temperature and raising the temperature of the concrete up and down just a few degrees. And by using the concrete instead of water storage tanks, we can eliminate the water storage tanks in some of our jobs. And we can always certainly make the water storage tanks much smaller in all of our jobs by using the concrete as part of the storage control system. Solar and backup for pools and spas, that's just a no-brainer. If you have a pool or spa, you want to control the free heat and put free heat in there whenever you can. Ice melt, same thing. You want to solar heat your ice melt after a snowstorm if you can. Domestic hot water, instant water recirculator controls. The DHW recirculator can be an enormous energy disadvantage in even small houses. I mean, if you just run a recirculator from the hot water heater out to the faucets and back to the water heater 24 hours a day, you can pull all of the solar heat out of the tank in just a few hours and waste it just recirculating it. So our control system has intelligent recirculation control. There's 5 different ways you can control the hot water recirculator, and you pick the way that's best for your job, and then you use the least amount of electrical pumping power and the least amount of heat waste from the water heater by controlling the instant water heater recirculator. Overheat controls of the panels and tanks has to be built into any solar heating system. You never want your storage tanks to overheat, you never want your floors to overheat, and you never want your solar collectors to overheat. So all of that has to be thought out, the worst case scenarios, and then any way that these things can overheat must be prevented very reliably by the control system. And so that's part of our control system, but most of your old school solar heating systems were deficient in overheat control. They'd have maybe 1 or 2 ways of controlling overheat, and they didn't work very well all the time. They weren't 100% reliable. Night sky radiant cooling, we have that built into our control system, and I'll talk more about that in a minute. And then BTU energy monitoring and data, we actually record the state of everything in the heating system every 5 minutes forever, whether you like it or not. So if you want to know what happened, last week or last month when the homeowner said they saw something funny happen, you just look at the data and you can figure it out. Oh, this thermostat was disconnected, or this heat setting was turned up too high, or this control didn't make the right decision, and then you can adjust it over the internet by remote control most of the time. And also BTU energy measuring, we measure all the BTUs going into the building from every heat source, and we display it as part of our dashboard display of our control system. And then, of course, the last part of this, Claudia already mentioned, is that for the homeowners or the people who live in the house who are not computer people, you don't have to go to the computer to run the system. You just have to go to the thermostat, turn it up and down. And then also our thermostats have a few extra functions like a solar-only switch so that you can just not heat the room with anything but solar if you want to, and an auxiliary switch which gives more priority to holding the temperature at a constant level. Say if you have an elderly guest or a sick child or something, you might want to hold the temperature in the room much more constant, and so you use the auxiliary switch to do that. But the normal function switch on this room thermostat allows the controller to decide the optimum balance between heating the room up to the comfort target temperature or not, or how close to the comfort target temperature will it allow it to go without burning extra conventional fuel. So let's see, I'll continue here. And the way that we connect our system to the internet is through the local area network in the building or in the house. Most buildings these days have a local network router, and we plug our control system. Here's our control system down to the right. You plug it in with an Ethernet cable, a Cat5 wire, into the local area network, and then in the house, the computers in the house that are connected to that network can view the control system as a kind of a dashboard. So you can actually drive the heating system through your computer, kind of like driving a car. But then also the home local area network is often connected to the internet, to the outside, through what we call cyberspace. And when it's connected to the outside, to the internet, anyone with the right software and the right passwords can also look in on this heating system. So the installer might want to have the password for a system he installed, and from his office he can check it and make sure it's working right, and do diagnostics and adjustments from the installer's office. And of course, we at Solar Logic do this all the time with all of our systems. We kind of watch over them, and especially when the owner or the installer calls us with questions, we'll go and look at it by remote control over the internet. So one big innovation for solar heated homes these days is internet connectivity, which allows you to do data logging, which is recording everything that the heating system is doing, metering it, monitoring it, and displaying the energy. You can see how much solar went in. You can see how much boiler heat went in. You can actually read off the display the solar efficiency of your building. And you can see where all the heat went, whether it went to the water heater or the floors or what have you, or the swimming pool. Monitoring and text alerts. If anything goes wrong, the slick control system will actually send a text for some of the most critical things. Like if the pressure gets near zero in the glycol loop, it'll send us a text. If the collectors are super hot but the heat isn't arriving in the boiler room, it'll send us a text. So, you know, very common errors that happen in hydronic heating systems are caught and alerted and can be fixed before they become a problem that way. And then, of course, remote control operation and adjustment, that's something totally new with solar heating systems, where you can operate the system and adjust it over the internet remotely. Now, one of the most important things with solar heating systems is to keep it from overheating. And here's 7 ways that are commonly used to keep solar heating systems from overheating. And this is most likely to happen in the fall when you have a lot of solar collectors, but the fall weather is warm, and so you don't need the heat for heating your house. And so overheating can happen just because the weather is warm and you have a lot of solar collectors. And another reason why overheating can happen is if you have a power failure, where the pump that pumps fluid through your collector suddenly dies, and it's still a sunny afternoon, and so the collectors heat up. Now, these first 6 ways of controlling overheating are commonly used even in the old school solar heating systems. But the seventh kind of overheat protection for your solar collectors is something we do here in New Mexico that I've never heard of very much being used anywhere else. But it's 100% reliable if you do it right, and even during a power failure. Even if your pumps, all the pumps in your hydronic heating system fail, including the solar pump, this thermosiphon self-cooling of the collectors will still cool your collectors and prevent them from blowing steam. And here's how it works. You take your collectors and you add cooling fins to the back by connecting them at one corner of your collector array. The corner that's usually capped off is the cap is removed, and the top of the collector has a cooling fin attached to it, and that cooling fin drops behind the collectors at a slight tilt and comes down and connects to the other end of the collectors where you usually have a cap through a swing check valve. And so let me show you the back of the collectors to make this more easy to visualize. You see the fins come off the top of the collector bank and drop down at a tilt downhill all the way to the bottom of the collectors. So when you have a power failure, what happens is, I'll go back to this, when you have a power failure, the pump stops, and the pump that was pumping fluid from the bottom of these collectors up and out the right-hand top corner, the pressure from that pump was holding this swing check valve shut. So there was no flow through the fins while the pump is on. But then when the pump fails or has a power failure, the heat building up in these collectors causes the fluid to rise because hot fluid is less dense and rises, and so it rises to the top header, and it can't find its way out the right-hand side because the pump's kind of in the way there. So it finds its way out the path of least resistance, which is out the other corner through the fins. And in the fins is cool fluid, and as hot fluid slides in the top, as it rises and comes in the top, the cold fluid slides downhill and back into the bottom of the collectors. And so that's known as thermosiphoning. It's the flow from the hot collectors to the cool fins and around is driven by the heat from the sun. It's known as a thermosiphoning cooling loop. And we use this these days on every system. Just about every system we put in for the last 3 years has had thermosiphoning cooling loops because it keeps the glycol from boiling during a power failure, and it keeps it cool so that it doesn't wear out prematurely and become too acidic too quickly. And so everything lasts longer and everything stays cooler, and that makes solar heating more reliable. In fact, it makes it 100% reliable if you do it right. So that's thermosiphon self-cooling. Also, because we monitor everything we do over the internet, we can see whether the thermosiphon self-cooling is working or not. And this is a graph proving that indeed it does work. If we over the internet turn off the solar pump on a sunny afternoon and we watch the temperature rise at the top of the collector, you can see the point at which the fluid in the collector gets so hot that it slides out into the cooling fins and opens the check valve, and the temperature drops, and then it kind of holds at a reasonable hot glycol temperature for the rest of the afternoon by thermosiphon cooling. So this isn't something that we're experimenting with, and it's not theoretical. We actually do it and it works, and we monitor it and make sure it works. And we can help anybody who's doing solar heating mimic this installation of the cooling fins, because it's not patented or anything. Anybody can do it. Now let's talk about night sky radiant cooling. The way night sky radiant cooling works is when you put a plate of metal, and here's a plate of metal, for instance, like the license plate of a car or the metal top of your car or something, and it's clear out at night, even in the summer, what happens is that the night sky becomes a very, very, very cold heat sink. The equivalent temperature of a dark night sky is, 100 degrees below 0 Fahrenheit. I mean, outer space is very cold. So what happens is that the warmer surfaces on Earth radiate away to this cold heat sink up in outer space, up in the night sky, and the radiation happens so rapidly, essentially at the speed of light, that you can radiate away heat so fast that the surface cools off much colder than the air surrounding that surface, because the air has, if the air was going to reheat the surface, it would do it by convection, and natural convection is very slow and radiation is very fast. So you can get metal surfaces that are radiating to the night sky to drop well below the air temperature, sometimes 10, 15, or 20 degrees below the air temperature. And that's one reason why sometimes when you come out of your house late in the summer, in the morning you'll see frost or dew on top of your car, and nowhere else do you see it. And that's because the metal of your car was radiating away to the night sky and is much colder than the air temperature, and actually caused condensation to condense out of the air because it's so cold. Well, we use the same principle to cool buildings when we put, and the simplest way is in this diagram. This is like the very simplest radiant heat cooling system you can possibly do in this diagram. You can put unglazed radiator plates on the roof. And just like in that building in Los Alamos, we put unglazed metal plates on the roof, and we pump hydronic fluid from the floor through those plates. And that's what you see here. Here's a pump, and you tell the control system to turn on whenever the night sky is clear and cold, and it can be partly cloudy and still work. So we have a special way of sensing that with what we call a white plate sensor, where we sense how cold is the night sky, and then we turn on the pump and pump warm, say 73, 75 degree warm fluid out of the concrete floor up through the radiator plates, let it chill down a few degrees and come back colder. And so all night long, we're circulating fluid out of the floors up to the radiator plates, and we're pre-chilling the mass of the floor with whatever cold temperature we can get out of those radiator plates. And typically on a clear night, you can pull the temperature of the concrete floor. The surface temperature can come down 2 or 3 or 4 or 5 degrees, depending on how clear it is at night. And that may be just enough surface temperature depression, lower temperature on the surface of the mass of the floor to prevent the air conditioner from turning on the next day. And so that's how it works. You pre-chill the floor, and then you cross your fingers and hope that it's enough cooling to prevent the air conditioner from running. And most of the time, that's how it works. It works actually very well with radiant-cooled floors. And if you don't have concrete floors, but you have metal plate radiators in the ceilings or walls, then you would have to chill a tank and then circulate chilled tank water through the walls. It's probably the way to do that. But we like to use common construction. All of our suggestions that we're making in this presentation require only common construction, ordinary plumbing, ordinary hydronic heating equipment, and ordinary building construction techniques. There's nothing special going on here. You can solar heat your radiant heated hot water boiler building and build it any way you want to, as long as it's relatively well insulated, and it will work fine using common construction techniques. So here's a couple examples of installations. Like I said, I'm not talking about theory. I'm talking about things we've done that work. So here's a residential house that has solar heat collectors on the roof, and they are also used in summer to radiate away heat at night from the floors, the concrete floors in this house. So the radiant heated floors are heated by the collectors in winter and pre-chilled at night by the same collectors in summer. And these are glazed collectors, but they still will lose heat at night if you run them at night. And then here's unglazed collectors in a small commercial building in Taos, New Mexico, where we have these unglazed radiators that we run at night to chill the concrete floors in the commercial building. And we found that you get about twice as much cooling from an unglazed collector as you get out of a glazed collector, but you still get plenty of cooling out of a glazed collector. And for the price of running a circulator pump, the coefficient of performance for cooling is outrageously high. So that's why we do it. It's economically viable, it's technically viable, and it's just ordinary equipment being used in a different way under cooling control instead of heating control. So let me continue on here. And then just to prove that you can predict how much cooling will happen in different climates, there is a formula back here on this page. There's a formula here where you can look at the dew point in the weather records at night and the typical air temperature outdoors and the typical air temperature indoors, or that's the fluid temperature indoors. Anyway, with just temperatures and a quick calculation, you can estimate how much cooling you're going to get in almost any climate if you look at the dew point and air temperature records. And so I've done that here using that formula to predict how much cooling can I get in different cities around the U.S. And here in Los Angeles, in the middle of summer, you can get, this much cooling with a glazed collector and that much cooling. The dotted line shows how much cooling in summer right there. You can get out of an unglazed collector. In Denver, here's how much you can get cooling in summer. In New York City, you can actually get significant cooling in summer out of these flat plate collectors. How about Miami, Florida? No, it drops off to zero in the height of summer in Miami because of the humidity. The dew point humidity situation it prevents you from using radiant cooling in summer. But in the swing seasons, you get a little. So if you need cooling in the off seasons and you happen to have flat plate solar collectors, you can still use them. They just don't work in Miami, Florida in the middle of summer. Oh, and by the way, you can get plenty of cooling in spring and fall and winter from these flat plate collectors by running them at night. And that's not such a far-fetched idea if you have a commercial building that needs to be cooled even in the spring and fall, or even in winter some commercial buildings need to be cooled. So it's a source of almost free cooling, and you can use these formulas and some weather data to figure out how much cooling can you get month by month. And pretty much anywhere in the United States, except the most hot and humid places, it does work. So moving right along, here's 6 things that if you're thinking about radiant night sky cooling, you should probably realize. And it doesn't work like an air conditioner. It's more like an economizer cycle where you turn it on when you can do it and you turn it off when you can't do it. So it's not like on demand like an air conditioner. And that's the most important thing to keep in mind. It's more like it's solar heat in reverse is really what it's like. I mean, you know, when solar is there, you take it and you store it or something. And when radiant cooling is there, you take it and try to store it or use it directly. So it's kind of like solar energy, but it's for cooling. But there's real efficiency advantages. That's the bottom line here. You can use it anywhere in the United States where the humidity isn't terribly high in summer, and it's got real efficiency advantages. And I've actually figured out the coefficient of performance for some of the radiant night sky cooling systems we have out in the field, and they vary from anywhere from a coefficient of performance of like 15 up to 50, you know. And when you think of a ground source heat pump having a typical coefficient of performance of 3, well, we're doing way better than 3 with radiant night sky cooling. We're doing at least a 13 or a 15, if not better, for coefficient of performance. And then, of course, we do have actual installations that we monitor and study. And the Los Alamos Eco Station is one of those facilities where they have significant radiant night sky cooling panels. They're quite large, and so they can get a lot of cooling out of them. And so since now that we have an intelligent control system there, we can watch it over the internet. And this is what happens. The solar heat collectors that are on the south wall produce this much heat month by month. So here's the winter, here's the summer, solar heat coming into the building being used, and then as winter progresses the next year, the solar heat comes in again. So it's this U-shaped solar heat delivery curve over the year. But look at the solar, the radiant night sky cooling panels. This is the cooling results. The guys that live in that building turn on the radiant night sky cooling to chill the concrete floors in summer, and we can measure VTUs coming out of the floor, and it's significant all summer long. Every month you get significant chilling, and every month it's kind of like the equivalent of running a large window air conditioner for 3 to 5 hours per day, chilling your concrete floor. Oh, okay, thank you, Claudia. Yeah, I've been pointing at things with the cursor on my mouse, and apparently you cannot see that, so I'm sorry about that. So let's just talk about other ways of using this technology that I just described to you. The standard solar hydronic heating system with standard intelligent controls can also be used not just for solar, but for any kind of heat. Any heat that you can use to make hot water and put into your hydronic heating system, we can control it. So here's some examples, and again, this is what we do. I'm not talking theory. We actually do this. So out in the field up in Colorado, we've done, here's an example of a biomass boiler where you fill this combustion chamber full of cordwood and fire it off and make 700 gallons of hot water, and then you pump that around, and you kind of control that the same way you control solar collectors. Whenever the heat's there, you use it, and the intelligent control system figures out where to put it, either to store it or to put it in the concrete floors. Or in this case, in Colorado, this is a fish farm, so we put the heat into the 3,000-gallon fish tanks where they're raising fish. Down to the right, there's a geothermal heat pump system. Geothermal heat pumps typically they pull heat out of the ground and then they make hot water in a water tank. That's what they do. So you can attach that warm water tank that's heated by the heat pump to the same primary loop system that I just showed you and control it with the same intelligent control system and use the geothermal heat pump instead of a boiler or along with the boiler and along with solar or not. So heat pumps and wood biomass boilers and then any source of waste heat that you can think of. Here's an example of something we did with an engine generator where it's like an automotive engine with a generator it's used as a backup electric system on a remote location. And we added a flat plate heat exchanger off the side of the engine generator so that the engine, when it's running, the so-called water pump in the engine pumps antifreeze through one side of this heat exchanger, and on the other side, a hydronic circulator pumps boiler fluid through the heat exchanger and sends it off to the primary loop. So whenever the engine runs, we treat it kind of like it's a solar collector. It's free heat. It's running anyway. It's making heat. So then we tap off the heat and send it around the primary loop, and the intelligent control system just sends it to somewhere it can be used. And this improves the fuel efficiency of an engine generator by a factor of 3. If you don't tap off the waste heat from an engine generator, you're wasting about 80% of the heating value of the fuel that's being burned in the engine. 20% comes out as electricity. But when you tap off using a heat exchanger like this, you can save half of that wasted heat. So you're bumping the system efficiency of the engine generator up to 60% instead of just running it at 20% to make electricity. And here's an AutoCAD version of the standard solar hydronic heating system that we just about always configure them this way with a primary loop. And in this case, we have an engine generator down to the right, and whenever the engine generator is on, it can send heat into the primary loop. The boiler can send heat into the primary loop. The solar can send heat into the primary loop, and it's all in the right temperature order, so one thing can preheat the next thing, which can preheat the next thing in the right order. And then the domestic hot water, the radiant floors, and in this diagram there's a swimming pool. And by the way, we quite often build swimming pools around here with radiant heat tubing in the concrete shell of the pool. So we can send solar heated or boiler heated or engine heated hot boiler fluid into the concrete shell of the swimming pool to heat it. And we've done that a number of times, and it just works great. So that's another market where you can sell radiant heat tubing in concrete, is the swimming pool market. So I'm going to bring this part of the presentation to a close with this philosophy here, which we use this philosophy all the time with our alternative energy heating systems, and that is, if you're going to sell alternative energy to the owner of a building, it must be an upgrade. It cannot have anything weird about it. You can't tell the homeowner to throw a tarp over the solar collectors or to turn a valve to make the heat go in the right direction manually or something like that. It must be an upgrade, and so all of our systems are completely reliable and completely automatically controlled and completely verifiable. You can watch them work and verify that they work. And then the other thing is, it must feel, not only be an upgrade, but it must feel like an upgrade to the homeowner. It's like if your homeowner it's like buying a new car for the homeowner. It's got to feel like it's way better than the hydronic heating system they used to have. And that's our philosophy. So with that, I think that is the last slide in my part of the presentation. And I'd like to turn this back over to the moderator.
Oh, what's his name is Thank you very much for that, Bristol. It's quite obvious that you are a pioneer in the field, and it's evidenced by the arrows that are in your back.
Okay, yeah, right, the bleeding edge.
Yes. How many years have you been doing this?
I've been doing standard hydronic heating systems in this configuration for about 16 or 17 years, but I've been doing solar heating of all kinds since 1977, or actually since 1975. So that's like 40 years, isn't it? I'm a solar heating guy that's been around for 40 years.
Regular guru.
Yeah.
I'm infatuated with that radiant cooling stuff. I look at some of these snowmelt systems that are laying out there. In fact, I'm actually familiar with a project up in Aspen, Colorado that uses their cooling tower, well, the snowmelt system as their cooling tower. They have conventional DX equipment within the building that they use to generate chilled water. And instead of having a cooling tower, they actually use their snowmelt system. Yeah, a big snowmelt field is a good place to dump heat and get cooling back. And yeah, that works great. I'm also familiar with a company out in California that took a raised metal seam roof and had an extra couple of grooves rolled into it, and his original intent was to use this product as a radiant ceiling heating installation, and it automatically had its own standoffs on it to be able to hold it down so that you could get the insulation, etc., behind it. Yep. And he's since moved on and said, you know what, this thing makes a great roof. And as a roof, it's basically an unglazed solar collector, which can be used directly or indirectly through a heat pump. And he says, I also have the ability to be able to use that roof as my cooling source for being able to do night sky radiation cooling at night. So there's a lot of innovation coming to the forefront, and you're obviously on the bleeding edge, as you said. Yep. Well, I've actually used one of those PEX embedded metal roofs and put data logging equipment on it in Albuquerque, New Mexico, almost 10 years ago. So I'm familiar. At that time, the guy was calling himself Dawn Solar, D-A-W-N, the unglazed metal roof guy with PEX behind the metal roof in special standoffs. And it could be the same guy, I'm not sure, that you're talking about. But I know that he still is out there doing these unglazed metal roofs, the guy I know. He just has a different company name now. No, I don't think it's the same guy. This guy's got a whole completely different division. One thing interesting about his system is that he's proving in his market, he's kind of in Central California, that with his radiant ceiling heating system, he can provide 100% of the heating and cooling needs of a building for actually less money installed than a typical gas forced air system. Yeah, well, that's really exciting news for the radiant PEX industry because it's always good to find new applications for the old tubing, and that's a really good application, especially if it does all the heating and cooling. You know, if you've got the energy balance in the building done correctly, and then you put in this material, you're done. And there's no moving air. There's no blowing air or scorched air happening in the building. One of our guests had asked a question from Kurt Albachart, wanted to know if it was Bill Miller, perchance, that was doing the roof radiant cooling. Does that ring a bell for you? I don't actually remember his name at the moment. I'm sorry, I have sort of a block in that part of my brain right now. Well, you've been doing it since '77. You're allowed to. Yeah, but if you research the name Dawn Solar, you'll find out who it is. D-A-W-N. Yeah, that's an integrated solar system, I think, is another name that they go by. Integrated solar collectors. Yeah. Yeah. I had another question for you. The check valve that you use on providing cooling, self-cooling for your closed-loop solar collectors. It noticed that it's not only installed with the flow running from top to bottom, but it also appears that the check valve is installed upside down. In other words, the top is on the bottom. Is that correct? The swing check valve that's on those solar collectors? Yeah. Yeah. Let me take. No, it's not. It's not upside down. What it is it's a Y check. So it has a 45-degree tilt to it, and it's up, and it's right side up. Okay. Yeah, yep, and you can actually see the hinge pin there. The flapper has the hinge pin on the top. Right. And that's the proper way to do it for thermosiphoning. What you want is a flapper that's very easy to open with almost no pressure. You want it to be able to open with any slight variation in the balance between the hot fluid and the cold fluid. And so I've installed that one with the flapper essentially vertical, where I tilted a 45-degree Y check on a tilted piece of pipe so that the flapper is actually vertical, straight up and down. So it's hanging in somewhat of a neutral position, and it's really
That's
not
right.
against the seat, and it's not against the stops.
That's right. It's got neutral pressure more or less, and it takes almost no pressure to open it. And then to snap it shut, the pump when the pump pumps high pressure into the bottom header, it makes so much pressure that it snaps shut no problem.
I have a similar cooling system for my array up in the mountains of Colorado, except that I use a 12-volt DC pump, and I have a three-way diversion valve, and I drilled myself a small, shallow, I think it's 15 foot deep hole into the blue shale that my house is built on up there, and grouted it in so that if I get hit by a power failure, it opens a three-way valve and turns on the PV pump. Well, everybody goes, well, what if the sun's not shining? Well, if the sun's not shining, I don't have to worry about stagnation now, do I?
That's right. No, a PV-powered cooling system is just as good as this, because you only need cooling when the sun is shining, and if the sun is shining, you can run a PV pump. So, but the only drawback is if the pump fails, then you don't get cooling, the PV pump.
Right.
And I've used hundreds of PV pumps on systems. I pump collectors with them. I pump cooling systems with them. And they're not 100% reliable, I'm afraid to say. And this check valve is. This check valve is pretty much 100% reliable.
I've actually used that same application where the check valve is hung like that for makeup on commercial systems. You've continuously got leaks in a commercial hydronic heating system, an apartment complex, packing glands around valves, just pump gaskets, a lot of different places to lose fluid. Our insurance company required us to install what we used to call a fill-safe system, which is essentially two expansion tanks, one that acted as a reservoir for fluid to be charged into the system to compensate for air elimination, and the other which would be the normal expansion contraction compensator. But on commercial systems like that, you've got so many leaks that if you don't make a makeup connection, you'll eventually hit 0 psi and then the boiler is going to lock out. Right. So we incorporated that same check valve in a reverse flow type situation, and as long as it's just a real subtle flow of water, then it'll allow that water to go into the system to compensate for water loss. But if you freeze and break a line, or as we found out the hard way, if somebody's using your system to water their marijuana plants, as soon as they latch onto that drain cock that's under the baseboard, connect it to a hose and turn that on, that check valve sees a huge flow, and wham, it shuts. Right.
Yeah, that's a great innovative way to use a swing check, is sort of to prevent a gushing leak from happening if it happens.
It causes the inspectors to look at it with a jaundiced eye and scratch their head and go, what the heck are you doing here?
Yeah, not everybody knows what that's about.
No, they don't. They certainly don't. Claudia, did you have anything that you would like to add? Take us back.
Actually, this has been great, and I just wanted to mention that we are available for your questions. So if you wanted to give us a call or send us an email, I can give those numbers out.
Yeah, absolutely, do.
Okay, so you can reach us by phone at 505-577-4633, and you can reach us through our website, which is www.solarlogicllc.com. solarlogicllc.com is our website, and you can send us an email from there.
Great. Spoken like a true marketing person.
Thank you.
And one thing that I wanted to also bring to the forefront here, which you can probably see my screen now, which now I'm showing you all of our members, is that you're going to be in Colorado next week. I forgot to put that onto our calendar of events for the Colorado Solar Energy Association's annual industry event, and you will be presenting there, will you not?
We're actually doing a full-day training on that Monday, and then we have an exhibit for Tuesday and Wednesday. So we have a full-day product training, which we break it into 2 parts. The first 3 hours is the design training, and then the second piece, 5 hours, is for installers to install the Slick integrated controller. So they learn all about the control software and the control hardware that Bristol just mentioned.
Excellent. Well, I tell you, my company just dumped a huge writing project on me that they'd actually kind of pre-warned me about a couple of months ago, and then they dropped it on me Friday and said, oh, by the way, this is due Wednesday. I was planning on coming up to the show, but I think I'm going to be found with my...
Come to the show and I'll help you write it.
That'll work. How about you write it and I'll walk the show.
I wanted to mention also that all of our training sessions get NAPSEP credits, and they also get NEAT credits, and in some states they get plumbing journeyman credits too, continuing ed credits.
Does the name Les Nelson ring any bells with you guys?
I don't think so. Oh, you know?
I don't know where I know it. I don't know where I know him.
Les is one of the original conceivers of NAPSEP.
Oh, yeah.
And he actually works for IAPMO now. He works
Wonderful.
for the Green Plumber section on solar. So Les and I communicate on a regular basis. But in any case, if you're in Colorado and you would like to see an excellent show, I would strongly suggest that you go to the event. They always have some very good guest speakers, usually consisting of former governors and people that have really kind of put Colorado in a position that they have as it pertains to the percentage of solar that we're doing here within the state with Xcel Energy, our power provider of choice in most areas. We do have some other nonprofit co-ops that have a substantial chunk of the holdings here too, but I think people-wise, Xcel Energy has the largest quantity of people that are part of that process. So quickly, let me get back to Colorado.
They've got a good group in Colorado for solar thermal too. They're making great strides in policy as far as getting the kind of credits that you can get with a PV system. And PV all over the country has there's tax credits for PV, 30% federal tax credits, and state by state there's other tax credits. But solar thermal also has those 30% tax credits, as does geothermal. And so those tax credits are significant, and when you go on a state-by-state basis, there's all different kinds of incentives for different kinds of technology. And solar thermal in Colorado, they're moving towards getting some additional incentives. And all those, by the way, all those incentives for renewable energy can be found on desireusa.org. It's DSIRE.org. I'm sorry, desireusa.org. So it stands for the database of state renewables and incentives.
Yeah, make sure you don't put an E in there or you'll end up on a website you didn't want to end up at.
Right. Not desire, but desire.
All right. Well, I would like to thank you both very much for taking time out of your busy Saturday schedules to show up here. Generally, at this point, we open it up for any questions, but I don't see any questions from our attendees. I know I've got, I can tell you, I've got Gaylord Olson, who is attending, and also Kurt Halbershart. I don't know if you know Kurt, but Kurt is very sharp as it pertains to controls. In fact, I think I'm going to unmute Kurt's microphone real quick and see if he has any questions that he would like to ask you. Hold on just a second. I can get him to unmute. Unmute. There he is. Hello, Chris.
Good morning and welcome from a little bit south of you in Silver City.
All right. Hello.
Another New Mexican.
Had a couple questions for you. Who makes 4x4 collectors?
Those collectors are a standard product made by Solar Skies.
Ah, okay. Interesting. And then do you guys do you have a standardized drainback design as well as Glycol?
Yes, we do. We've done a number of drainback systems for the folks who like that sort of thing, and all it requires is that you replace that system heat exchanger with a drainback tank and a heat exchanger in it, and then you connect the heat exchanger from the drainback tank to the primary loop with two closely spaced T's, and that that makes the solar part work the same way with the same controls, but with the limitation that you can't add, say, ice melt loops and outdoor swimming pools and what have you, because the glycol loop isn't there anymore.
Right. Yeah, of course. You'd have to isolate those separately.
That's right.
And then there was another question on your thermosiphon overheating thing. I'm assuming that the solar pump then needs a check valve to keep the pressure from pushing back down, or is just the head loss enough to stop that?
No, every secondary that we have on our standard diagram has a spring check right next to the pump, and that includes the solar pump.
Gotcha.
So that provides enough resistance to make the thermosiphon flow go in the right direction.
I expected that, but I didn't see a detail for that. So.
Yeah, no, that's a good question.
Plus it also stops any ghost flow, right?
That's
on
right.
The secondary side.
Yep, spring check valves on every single secondary.
That is unique. I've never seen that before in the industry, and I remember when we first started doing primary, secondary pumping, and Holohan was a big proponent of that, and there was always one pump that did nothing but make the water dizzy. It just sent it in a circle.
Yeah.
It's like, well, why do we do that?
Right. That's the primary pump that I sometimes eliminate with my weird check valve system.
I noticed in one of your later drawings that it was still in there because you didn't have checks on the secondaries, which is a fine option, but I like yours better.
Yep, you can do either or. And on larger systems, you wind up sometimes wanting a primary pump. But on these smaller systems, you can sometimes eliminate it, and it works fine if you do it right.
Mm-hmm. Yeah, I've never seen an undersized pump, to be quite honest with you, in my 38 years of doing this.
Mm-hmm.
Every pump you ever see is always oversized, so seriously, that would be a major issue.
Yeah, well, part of our clever scheme standardizing all this stuff is to make the electrical efficiency as high as possible along with the thermal efficiency. So quite often we're putting in really small pumps compared to what other plumbers usually do. And when we work with conventional plumbers and we hand them a drawing and we show an alpha pump that pulls 50 watts or less, and then they get all nervous about it, and they put in a 2699, and it's like got 2 amps going through it. It kind of messes up your electrical efficiency. So, all I can say is if you get a drawing from us and it's got specs on it, just follow the recipe and it'll work, because the specs have been worked out over a long period of time.
Well, if a little pump does a little good, a lot of pump will do a lot of good,
yeah,
won't it?
Right.
That seems to be the theory out there, and with the DCCM circulators that we have now, it's like totally different world.
Yeah.
It's like a tractor engine.
Mm-hmm.
Well, I don't see that we have any other questions in here. And I think with that, I'm going to go ahead and let everybody know that the next person that's going to be coming up in 2 weeks will be Paul Roars of Lochinvar. And I don't know if Paul's coming in by himself or if he's going to be bringing Michael or somebody else with him, but this is my favorite boiler company, and I've dealt with just about every boiler that's out there on the market, with the exception of the last 3 years when I've not been allowed to work on any boilers. And the one thing that interests me about Lochinvar is that if you make a suggestion to them as it pertains to their product, generally speaking, the next time you get that product, it will probably have that change made to the actual product itself.
Mm-hmm.
I mean, when they get a recommendation, they have a real quick meeting of all their production managers, and they pull the switch on that thing, and the next thing you know, it's on the floor, and it's done. And they start doing it. I mean, it's got to make sense for them to obviously do it. It's not something that would be aesthetics like, oh, you should paint it blue instead of gray. But these people have also taken the controls that everybody else has. I mean, everybody that's got a mod con boiler is basically dealing with the same heat exchanger, the same gas valves, the same blowers, and in most cases the same controller. But they've taken this controller and they've turned it inside out, and they're allowing the contractor to do a lot with this. They now have a wireless outdoor air sensor, which is a real lifesaver in retrofit considerations. It's virtually impossible to sneak a wire from the mechanical room all the way to the north wall of the building. But they've now got a wireless function where you can use that for your outdoor sensor. And they are also one of the first boiler manufacturers to bring the internet to the boiler itself. I mean, my boiler, I have one of their boilers at my house up in the mountains. and I can connect to it, but I've got to go through a third-party software program to be able to talk to the computer up there to gain access to the onboard PC on that boiler. But they've now got it set up so that it's Wi-Fi. As long as you've got a Wi-Fi connection in your house, then that boiler is online. It can send you emails. You'll know your customer has a problem before your customer knows they have a problem, which is kind of scary. But they are a very innovative company, and I'm looking forward to Paul's presentation, and I'm also twisting his arm to become one of our instructors up at the Heat Spring site and put a course together on basic hydronics. You know, we've seemed to have forgotten the basics. We've gone off and showed everybody how to do primary, secondary, variable speed injection, all the different tricks, bells, and whistles that we've got in the systems, but we've forgotten to focus on the basics. You know, this is your heat source. This is your expansion tank. This is your circulator. Circulator has to go installed in this relationship to the expansion tank, otherwise you're going to have issues. And here's where you want to put your air separator. And so hopefully we'll be getting permission from the powers that be to be able to bring that up in the very near future, and we'll be one of our instructors that will be online providing additional education for our contractor base.
Mark, you just reminded me of something. This seminar has been a lot on design, but these days people expect their systems to be online. It is their expectation, and I think in the hydronics industry, you know, we all have to participate in the whole industry going online. We have a story that Fred tells about, you know, a customer, a system he was watching, and he saw that there was some aberration in the temperature measurements, and contacted the client because he thought it was you know, one of two things. One, it was somebody left the door open and they went on vacation, or maybe even or a window, or maybe somebody had broken into the house even. And so that kind of, you know, customer service, knowing how a system is supposed to operate and being alerted when it's not operating that way, it is the kind of service that people are have come to expect in every other industry. And I think as hydronics professionals, we should have that same expectation for ourselves.
Oh, I agree. I mean, it's great to be able to know the customer's got a problem before they know, and call them and say, hey, look, your computer and your boiler sent me a note that it's having an issue. I can come over right away, or you can call me when you run out of hot water. You know, it's your choice. And, you know, if it's Sunday night or something like that, then they know that at least they're going to wake up Monday morning and be able to go to work feeling clean and refreshed because their service contractor picked on a problem that they didn't know they had. And,
well, also with the controls that we use, we have actually complete control over the entire heating system. So most of the time, that it requires just an adjustment that you can make from your, you know, from your office, or we can make from our office remotely. I mean, it can take just a minute to find out what the problem is and make an adjustment so that there doesn't have to be a service call.
You know, 25 years ago, none of this existed. The internet wasn't even out yet. Al Gore had not invented the internet yet. Now here we are today, and you have the Internet of Things with the Nest thermostat is talking to cameras and talking to your clothes washer and your dryer and your refrigerator and everything else, and it's like there is no privacy in my life anymore. I've given up on that. I let everybody avail. In any case, thank you both very much for coming out and giving us this presentation. This presentation will be available probably by Wednesday, and I'll make an announcement of where it will be online and send notification to both Bristol and yourself, Claudia. And thank you again, and thank you to our attendees. And we will talk to you all in 2 weeks when we have Paul Roars with Lochinvar come in and talk to us about what the state of the art is with Lochinvar.
Okay, thank you, Mark.
You're quite welcome. Have yourself a good weekend, and we'll talk to you all in 2 weeks.
You too.
All right, bye-bye.
Take care.